Hello and welcome to this AQA Further Math Statistics video, the last in the series Discrete Random Variables, one looking at linear combinations of random variables. So you should recall from work that we've done before that the expectation of a discrete random variable x is the sum of each outcome for that particular random variable xi multiplied by the probability of getting that particular outcome, and the variance is obtained by this formula here by looking at the value of the expectation of x squared minus the expectation of x, or the mean of x, squared. And those are the results that you should be familiar with. So if we now look at ax plus b, so we're looking at two constants a and b. One of them is multiplying our random variable x, and one of them that might be positive or negative is being added on. We know the definition of the expectation of x. What is the expectation of ax plus b? And if we just go from the original definition, the expectation of x is the sum of x multiplied by the probability, but this time instead of x we have ax plus b multiplied by the probability of obtaining that value of x, and that we can split into two summations and add those two together. So we can write it like this, and then because a and b are constants, they can come out of the summation because they multiply every term in that summation. So we can then write it like this, and you should recognize this expression, and you should be able to think what sigma pi, the sum of all the probabilities, will give us. And if we look at that written out a bit more neatly for you, as I just said, the sum of all the probabilities is 1, so this summation here is simply 1, so we just get b. And here you should recognize sigma xi pi as the expected value of x. So the expectation of ax plus b is a multiplied by the expectation of x plus b. Now looking at the variance of ax plus b, the formula for obtaining the variance we are going to have to use, and instead of having x, we're going to have ax plus b that you can see looks rather complicated on this line here. And if we think about the terms we've got here, certainly the second term is fairly easy because we've already sort of sorted that out. We know the expected value of ax plus b is a e of x plus b, so we must subtract ae of x plus b squared. If we look at the first term and just write that as the expected value of a squared x squared plus 2ab x plus b squared, we can then use the definition of expectation to write that as sigma a squared xi squared plus 2ab xi plus b squared multiplied by the probability of obtaining that value for x, and then we have here minus a squared e of x all squared plus 2ab e of x plus b squared. And if we look on the next page, you can see that written out slightly more clearly for you, and so we clearly have minus in front of that, so these three terms are all negative. And here, if we use the definitions, if we take the a squared out as a constant, we're left with x squared pi here. If we take the 2ab out as a constant, we're left with xi pi here. And we have b squared multiplied by sigma pi. You should know what we do with the sigma pi. You should recognize sigma xi pi and also sigma xi squared pi. So simplifying that, The first term you should recognise there as a squared, that's e of x squared. Then we have 2ab, and this is e of x. B squared multiplied by sigma pi is simply b squared. And then all of the terms we looked at before, all negative. And the b squares cancel, the 2ab e of x cancel, and we're simply left with these two terms for our variance. And they have a common factor of a squared, so we can take that out and write this as a squared multiplied by ex squared minus e of x all squared, and that you should recognise as a squared multiplied by the variance of x. And so the variance of ax plus b is simply a squared multiplied by the variance of x. And there are two questions that often arise here. Why is it an a squared, not an a, multiplying the variance? And why does the b not have any effect on the variance? And I think a very quick way of just sort of seeing how that works is if you just put, say, 1, 2, 3, 4, 5, you can quite easily see that the mean or the expected value is 3. And if we scale it, we do a linear combination and we do 2x plus 5, we are going to get 7, 9, 11, 13 and 15. And it's pretty easy to see that e of y is 11, which is 2 times e of x plus 5. That's very clear, but if we look at the variance is actually the average of the deviations of each reading from the mean squared. So if we look, we're squaring them, so whether it's positive or negative doesn't actually matter. So if we just look at the distances they are away, 2 is 1 away, 1 is 2 away, and similarly 4 is 1 away, and 5 is 2 away. If we look at it for y, 9 is actually 2 away from the mean, and 7 is 4 away. And similarly with 13 and 15. And so when we average these distances away from the mean, they're double what they were before, and they're also going to be squared. So you will be able to see very clearly that the variance of y is 4 times the variance of x, and the fact that we've added 5 on, the b if you like, doesn't make any difference because the actual values don't affect the variance. It's how far each value is away from the mean that affects the variance. If we look at the outcomes we've found now, e of ax plus b is a multiplied by e of x plus b, and the variance of ax plus b is a squared multiplied by the variance of x. And you should learn those, and you can just use them directly if required to do so in an exam. If we look at an example now, first of all focusing on expectation. X is the score on a fair six-sided die, so x will have the outcomes 1, 2, 3, 4, 5 and 6, and the probability of getting each outcome will be 1/6. And we are looking at y, where y is x doubled with 5 added onto it. And we have a discrete uniform distribution here, so the expectation for x is a half of n plus 1, so 6 plus 1, so that would be 7 over 2. And we know that the expected value of y would be 2 multiplied by the expected value of x plus 5. And if we look at that written out a bit neater for you here, so we got this far, we know the expected value for x is 7 over 2, which is here. 2 multiplied by 7 over 2 plus 5 gives us the expected value for y as 12. So for our discrete uniform distribution, the variance is 1/12 n squared minus 1, so for this it would be 1/12 multiplied by 36 minus 1, And remember, the variance of ax plus b is just a squared multiplied by the variance of x. So the variance of y would simply be 2 squared multiplied by the variance of x. So variance of y is going to be 4 multiplied by, and this we can simplify to 35 over 12. So it's just 4 multiplied by 35 over 12. And again, you can see it written out a bit more neatly for you. So it cancels down to 35 over 3, or 11.7. Very simple to do. And that concludes this series of videos.